for section 6.2 here, and a continuation, all of chapter 6 is really going over this confidence interval stuff just for different types of distributions. So I made a note here first of all that whenever we're trying to decide what type of distribution you use, one page that you can reference here to help you is page 322 to try to decide first of all when to use a t-distribution versus a normal distribution, of which table you're going to need to use and how to use it type of thing. So in this case, we have that you randomly select 30 restaurants and measure the temperature that they keep their thermostats at during the summer. The sample mean temperature is 74 degrees Fahrenheit with a sample standard deviation of 3 degrees. And we want to construct a 92% confidence interval for the population mean temperature, assuming that the temperatures are approximately normally distributed. So this phrase here, approximately normally distributed, this means that the overall population comes from a normal distribution. So one of the conditions, first of all, if you're going to have a t-distribution that you would need, also for a normal distribution, if your sample size is a smaller one, so you'll want to refer to that page in terms of deciding which one to use. But in this case, we have a random sample of size 30. So if you look in that table, if your sample size is 30 or more, and it's coming from a normal distribution, then that means we use the normal distribution table. If the sample size is less than 30 here, then it's coming from a normal distribution, and we're giving sample values, like in this case how we're given a sample mean and sample standard deviation, then you use the t-distribution. You would still use the normal distribution if the mean and standard deviation were coming from the population instead of the sample. So those are some key features to look at there in terms of deciding which one to use. So in this particular case, we're going to have to use the normal distribution table again. After we get done going through it this way, I'll show you how you go about doing this. If you use the t-distribution, how you'd change this just slightly to calculate it in that case. So first of all here, if you're looking at your normal distribution table and those critical values, like we did in section 1, you'll notice that the 92%, 0.92, is not one of them that's already given to us. So what that means is we're going to have to solve for what the critical value is here using our normal distribution table. So the idea here, we can think of it in terms of our normal curve here first of all. And then if we're dealing with a 92% confidence interval, that means between our two critical values, so that's what they labeled as the negative z sub c and the positive z sub c, those are the critical values, that between those two, that there's 92% of the data, or 0.92 in here. So there's a couple different ways that you can go about finding it. Probably the easiest way here is to first of all figure out what portion would go on these two outside parts here of this normal curve. So if we have 92% in the middle here, that leaves there's 8% on the ends here, which means 4% on each individual end. So that would mean 0.04 on this end and 0.04 on the other end. Because remember, underneath the entire curve, it needs to add up to a total of 1, just like whenever you're dealing with probabilities, because these areas are also probabilities underneath the curve here. So if we have an area of 0.04 here down on this left end here, we can find that critical value there, just like we did in chapter 5 in the last chapter, by looking in the area portion, which remember is the center part of your normal distribution table, and we're looking for the value closest to 0.04 here. So in this case, if you're looking at it, there's one of them that says 0.0392. That's close to that. There's another one here also that says 0.0401 for the areas. So in that middle part there, those are the two that are closest to 0.04. But remember, you want whichever one is the closest. So this one is the closest to 0.04. So we want to use its corresponding z-score value. So if we go over and up to look at the z-score there, we get a negative 1.75. So this part here for this negative z sub c would be a negative 1.75. And since it's symmetric, that means the positive one is a positive 1.75. So that would be in terms of your critical values here. And then from section 1, we use that same formula for the margin of error. Remember, we need that margin of error before we can go through and find our confidence interval. So in this case here, for our margin of error, our capital E, we're going to have the critical value, which is 1.75. We always have a positive value for our margin of error. So we're always going to use that positive z-score value. And then we have to multiply that times the standard deviation over the square root of n, which is 30 for the n here. So here looks like we get approximately 0.96 if we round to 2 place values here. Remember, you want to go at least 2. You can always go out more if you want to there. So that's in terms of finding your margin of error. And then remember, in general, to then find our confidence interval here, we have to do our sample mean, which is our point estimate. So here, our sample mean here was the 74. You do that point estimate of 74, the sample mean, minus the margin of error first, because we want the smaller value listed first in our interval, and then the 74, and then plus the margin of error to get the upper value of our confidence interval. So if we do that here for our confidence interval, interval means we have this value ranging from the 73.04 that we get whenever we do 74 minus the 96. And then if we do 74 plus 0.96, we get 74.96. So what that means here is that we are 92% confident that our population mean would be in that interval. Let me try and write that out here. What this means here that we are, so if we're interpreting this, in other words, how we could write this out is that we are 92% confident that the population mean is between that 73.04 and the 74.96. This would be what's called your interpretation. The confidence interval. So some of these problems, it'll just ask for the confidence interval. Some of them might also ask for the interpretation. So you just write out whatever the confidence level was. That means that you're that confident that the population mean is between those two numbers. And then, like I said, if this sample size, if it had been less than 30 here, instead of being equal to or greater than 30, then we would have used the T-distribution. So you also want to know how to use that. You'll have some of that in your 6.2 homework. So if it was that type, you would have to look at the confidence level, which they list out confidence levels at the top. So part of the reason I didn't include that here is because 92%, you'll notice that if you're looking at the top part of that T distribution, which is on page 18, so right after the normal distribution stuff, confidence interval levels that they have there are 50%, 80%, 90%, 99, 98, and 99 are the only confidence levels that they give here. And then along the side, on the left side of that table, you'll notice DF. The DF there represents degrees of freedom. So if you're talking about degrees of freedom, so once again, you don't have to do this for this problem, but you'll use it some in your homework. So I'm going to just draw a line here, write that at the bottom here. The DF here in that table means degrees of freedom. To calculate that, all you do is your sample size minus 1. All your degrees of freedom is sample size minus 1. So to look up the values that correspond to those, it's pretty easy. You go to the confidence level that you have and the degrees of freedom that you have for that problem and see what value intersects if you look at both of those values. So it's similar to how you use the normal distribution if you have less values. You just have the degrees of freedom and your confidence level that you're looking at here. And we'll use this table along with that normal distribution table more once we get into chapter 7 as well. So make sure as you're working on the homework and stuff, you have questions in terms of how to use that table also, make sure to ask.